To continue on here with exception handling, let's look at using an actual object to do some of the heavy lifting we need for the try-catch block. So this is page 994. And what we're going to do is, the wrinkle we're introducing here rather, is right here. We have inside of the rectangle class that we have been, following along with here since, I don't know, a few chapters by now. We have an empty class declaration here inside of rectangle for negative size. So there it is, class negative size. And you can see on line number 13, it is empty. So what we're saying is, inside of our rectangle class, we can make a call to a negative size class that just happens to be empty. And in so doing, what we're going to do is create an object called negative size. Well, called whatever, but of class negative size. So as we continue down here, you'll notice we have the rectangle.cpp, and the new wrinkle we have in here is we have our same set width and we have our same set length, but this time if width is less than or equal to 0, because it's not going to work with negative numbers either, and we have a length that is less than or equal to 0, we are going to say throw negative size. And remember, negative size with the parens right there is going to create an instance of the negative size class. So we're going to have an object of it. So what is that going to look like? We are here, this would be with our main, right? So as we continue down, here is my try catch block. On 21, we've got our try. So this is what happens if everything goes to plan, right? So if we have values for length and width that are greater than 1 or 0, right? So here goes my rectangle.setWidth with a width, my rectangle.setLength with a length, and here we can get our area. If something goes wrong inside of here, if by having made these two function calls, a set width or a set length, if the result of either of those is a thrown exception, we come here to line 28 where we are going to catch that. So here is rectangle, and you notice we have the scope resolution operator right there because we declared negative size inside of rectangle. We need to resolve where negative size is. So that's why you see that nomenclature right there. So we're saying catch if you find that there is a negative size object created. And then we can simply output our error here. A negative value was entered. So if we scroll down just a little bit, this is page, is it still 994? It's 996. We can see that if we enter a negative number here, we get the output from inside of our catch block. A negative value was entered. But notice what happens here. Because we threw an exception, if we would not have had the try-catch block, our program would have terminated and we would not have had any idea as to why. It just simply would have ended. Because we have the try-catch block, what ends up happening is we encountered our fault someplace here after line 21 when we encountered a negative number. Instead of simply failing out, because we have the catch, we're able to, at the very least in this example, output a message that lets you know what is going on. Now, what I'm going to let you do, as I have done in the previous example, is let you read through what is happening. It is this entire block of code, 16-4. In our code sample, we are going to walk through this. We are going to use exception handlers to recover from errors. So instead of just going like, what you gonna do? We are actually going to go and get back into a situation where we are running the way we expect to be running. But what I want you to do is look here at the code so that before we walk through it, you have at least an exposure to working with several try-catch statements, and then we'll work our way through it. So we can use objects to do this. We can use static members of objects to do this. We've got a lot of different ways that we can recover from an error. It's just you as the developer have to pick the right way to do it.